Today, we'll be solving LeetCode 36, valid Sudoku. We're given a 9x9 Sudoku board, and our task is to check whether the filled cells follow the rules of Sudoku. The board may be partially filled, and we don't have to solve it, we just need to verify that it's valid based on 3 rules. First, each row must contain the digits 1 to 9 without repeating. Second, each column must also contain the digits 1 to 9 with no duplicates. And third, each of the 9 3x3 subboxes must also contain the digits 1 to 9 without any repetition. So let's figure out how to approach this. We'll loop through every cell on the board and check whether it violates any of these 3 rules. To do that, we'll need a way to track the digits we've already seen in each row, each column, and each subbox. Let's first set up 3 lists, each containing 9 sets. The first list tracks what digits we've seen in each of the 9 rows. The second list tracks what digits we've seen in each of the 9 columns. And the third list tracks what digits we've seen in each of the 9 3x3 boxes. Now, we'll go through each cell in the board using 2 nested loops. The outer loop goes from 0 to 8 to cover all 9 rows, and the inner loop also goes from 0 to 8 to cover all 9 columns. At each cell, we get the value. If the value is a dot, that means the cell is empty, and we skip it. But if the cell contains a number, let's say it's the digit 5, then we need to do 3 checks. First, we check if this 5 already exists in the current row. Second, we check if it already exists in the current column. Third, we check if it already exists in the current 3x3 box. If the number is already present in any of those places, then the board is invalid, and we return false immediately. Now let's talk about how we calculate which subbox the current cell belongs to. The board is divided into 9 3x3 boxes, like a grid of boxes. We number them from 0 to 8, going left to right, top to bottom. To calculate which box a cell is in, we take the row index and divide it by 3 using integer division. Then we take the column index and also divide it by 3. This tells us the row and column position of the box in the 3x3 grid. To get a single index from that, we multiply the row part by 3, then add the column part. So the formula is, row divided by 3, times 3, plus column divided by 3. For example, if we're at row 5 and column 7, then 5 divided by 3 is 1, and 7 divided by 3 is 2. Multiply 1 by 3, and add 2, we get box index 5, which is the 6th box starting from the top left. Once we have that index, we check whether the digit exists in that box set. If the digit isn't in any of the row, column, or box sets, we add it to all 3, because we've now seen that digit in this row, column, and box. We continue doing this for every filled cell on the board. If we make it through all the cells without finding any duplicate digits, then the board is valid and we return true. This approach is efficient. The board is always 9 rows and 9 columns, so we're doing a constant amount of work. That means the time complexity is O of 1. But if we wanted to generalize this to a larger board, it would be O of n squared, where n is the number of rows or columns. The space complexity is also O of 1, because we're always using 3 fixed-size lists of sets. And that's how you solve LeetCode 36, valid Sudoku. Thank you for watching and let's keep learning.